There are many ways that blueprints can communicate with each other, either directly or indirectly. One of those ways is through a blueprint interface. With a blueprint interface, any blueprint in your project can subscribe to the interface's events and receive notifications and/or data, and any blueprint can call the events to communicate with other blueprints that are listening. No object needs to be aware of the other, and this decouples your logic from one another and eliminates hard-coded dependencies on objects in your level. We are going to start by creating a new asset type called an enumeration. This is simply an ordered list we can build and use to assist us in performing all sorts of tasks, from organizing stages to a level, giving a category to a UI button, using a string of text that makes up a given enumerator and using it as a label, or determining your logic based on the value in a switch node. I could go on, but I think you get the picture. The enumeration we will create first will be the list of locations that our user can teleport to. The Virtual Studio project does not identify the names of specific locations in the map, so we'll just have to make up some of our own. Let's make a new folder within our nav VR folder and name it enum. Right-click and select Blueprint and click Enumeration to create the new asset. Name it eMapPoint and open it. Another great thing about these assets is that they are reorganizable and scalable. Even if we edit the number of enumerators or the display names, they will be automatically reordered or renamed in any blueprint that uses it. Take advantage of them. We'll start with 6 locations that we can teleport to. I know it's not a large scene, but because we aren't developing this to walk around in, we still want to give our end user the opportunity to see the whole scene. Okay, so the first one will be entrance. Next is bottom posters, video screen, balcony stairs, balcony corner, and balcony back. Click Save and close this. Let's talk briefly about blueprint interfaces and how we will use them versus, for example, how they are used in the VR template inside of Unreal Engine. We will use them to directly call a function in the blueprints that are implementing them or listening for them. If I have 15 blueprints which are all implementing the same interface, and I use the node getAllActors with interface and call a function using a for each loop, all of them will perform that function, assuming they're using it. If that is not your intention, it's important to filter your calls in some way either before they are called or immediately after the blueprint receives the call, so there's no unnecessary memory usage. The template filters by whether the sphere collision in its hand blueprint is overlapping another actor. If it is overlapping and the overlapping actor implements the specific interface, it calls the function to attach it to your hand in VR. So the template is first indirectly using the interface, and only then is it calling a function contained within. Go to our interface folder and open BPI Studio Showcase. Let's make a few functions that we will use to travel the scene or set up our map. To create a new function, we'll click Add New and select Function. Name this one User Selects Pawn. As I had talked about in a previous video, we want to keep things nice and organized. Let's group together similar functions with categories. For User Selects Pawn, let's type User Selection in the category box. This User Selects Pawn function is going to be called when the user starts the game. We want to make it possible to easily add that PC pawn later, so we will create a new input of type bool and name it bPawnIsVR. So if our user clicks the Start Game in VR button, this will return true. If we have a Start in PC button and they click it, it should then return false, and then the game mode would receive that data so it spawns the correct pawn. Compile this. Let's create the other functions this interface will hold. Add new function and name it Teleport User to Location. Drag it into the user selection category and add an input of type eMapPoint. Name it the same. And compile. Next are some functions that will be widget specific, because just like actor blueprints, widget blueprints can also implement an interface. Create a new function named W_mouseclick and add it into a new category. But this time, let's also create a subcategory to place it into, as we'll have a few different widget functions. Type widget, vertical bar, general. Typing that vertical bar is placing a subcategory for you to organize with. Create another function named w underscore change view mode and place it in the same general category. A note on subcategories. They will count a space as a character. So if I type widget space vertical bar general, it will create a second widget category. Just keep that in mind. Next is w underscore toggle balcony, and we will place it in widget vertical bar top mode. Also add w underscore map point hover and place that in top mode with an input of type map point. Lastly, create a new function named move scene cam to new location. Let's place that in the category widget vertical bar preview mode with an input of type map point. I'm not going to go over what each function is intended to do here. Instead, we'll discuss it when we need it. Adopting Blueprint interfaces in your work can ease development, improve reusability, and improve the readability of the code in your project. From a single call to a Blueprint to update a score, to signaling an array of assets that all receive an update on a new game state, the Blueprint interface is an efficient way to handle communication in your game. Next, we'll create the VR pawn that is spawned when the player starts the game.